Welcome back students to your own channel of mathematics. Students, in our previous session we have seen one very important corollary in which a linear expression was involved. Students, the corollary was something like this. Integration of f of x dx was g of x plus c. Then integration of f of ax plus b. Did you observe what happened? X got replaced with the linear expression ax plus b. And then the answer was g of ax plus b, because integration of f of x is g of x. So I get g of ax plus b divided by the coefficient of x, which is a here. So this was a corollary that we have learned in our previous session. And I have told you that in our different session, in our other session, we will be learning how to write the formulas. The entire list of formulas that we have for the standard functions can be rewritten for linear expressions. So students, let's observe how to write the formula list for linear expressions. So, do you remember we had integration of x raised to n dx. So integration of x raised to n dx, if you remember, it was x raised to n plus 1 upon n plus 1, isn't it? Obviously plus c is definitely going to come there because it is indefinite integration. So we remember that integration of x raised to n dx was x raised to n plus 1 upon n plus 1 plus c. So students, now if I ask you the integration of ax plus b raised to n dx, the integration of ax plus b raised to n dx. So how much change do you observe here? The variable x got replaced by a linear expression. This is very important. Only x is going to get replaced with a linear expression, and it has to be a linear expression. It won't have a quadratic or a cubic or a power 4 expression. It has to be always a linear expression. So power n will remain as it is. Only x got replaced with ax plus b. So the answer is going to be exactly same as x raised to n. In place of x, you can call it as a capital X. So capital X raised to n, capital X raised to n. It will give you answer capital X raised to n plus 1 upon n plus 1. So in place of capital X, what do you have here? You have ax plus b raised to n plus 1 upon n plus 1. The only thing we should always remember is to divide the entire answer by the coefficient of x. Coefficient of x is a. So this entire answer will get divided by a. So the entire answer gets divided by a. So I can write it here only into a. And as usual, a plus c should always be done because we are considering the indefinite integration. So did you observe what happened? Integration of x raised to n was x raised to n plus 1 upon n plus 1. So integration of x is getting replaced with the linear expression ax plus b. Answer remains same. Ax plus b raised to n plus 1 upon n plus 1. Always to remember is the coefficient of x. Divide the entire answer by the coefficient of x, which is a over here. So hence the entire answer has been divided by a. So likewise, if I now ask you integration of 1 upon root of x dx. So do you remember the answer was what? 1 upon root x dx. It was 2 root of x plus c, isn't it? So here also, now if I ask you integration of 1 upon root of ax plus b. So integration of 1 upon root of ax plus b, it is going to be 2 root of ax plus b. Always to remember dividing by the coefficient of x, which is a, and plus c, isn't it? Let's move further. Integration of 1 upon x square dx. So do you remember it was minus 1 upon x plus c. So here also, if I write integration of, observe carefully what do I have here? 1 upon ax plus b the whole square. So everywhere I am simply replacing the variable x by a linear expression ax plus b. Linear expression is an important term over here. You cannot have any other term other than the linear expression. So students, what answer is going to come? The answer is going to come minus 1 upon, it because x here, the place of x is taken by ax plus b. So minus 1 upon ax plus b. Not to forget, you always remember, divide the entire answer by the coefficient of x, which is a. So divide by a. So I can write it here into a. Isn't it? And obviously plus c is going to come there. So this was integration of 1 upon x squared dx. Let's move ahead, people. Integration of, if you now remember, 1 upon x dx. So integration of 1 upon x dx. Do you remember it was log of x? Or better you should say log of mod of x, because log of negative number. At this moment, we should say that log of negative number is not possible. At this moment, let us assume that log of negative number is not possible. Hence, x should always be kept inside the modulus sign. So integration of 1 upon x dx is log of x. Did you observe the difference? Here x is in the denominator. X has power 1. It is a linear term. X has power 1. It is a linear term. 1 upon x square is not linear. Answer is not log of x square. So this difference has to be very clearly understood. 1 upon x, the integration is log x. But 1 upon x square, the integration is not log of x square. It is minus 1 upon x. So students, if integration of 1 upon x dx is log of x, then integration of 1 upon ax plus b. 1 upon ax plus b. So just replace the variable x by a linear expression ax plus b. So your answer is going to come log of ax plus b, and always remember to divide by the coefficient of x, which is a, and divide plus c, isn't it? So that's integration of 1 upon x. Let's move ahead. Let's use some trigonometric formulas. So integration of sin x, if you remember, integration of sin x dx, was it minus of cos x plus c? So here also integration of sin of ax plus b dx is going to be minus of cos of ax plus b upon a plus c. Got that? Let's move ahead. Let's write integration of cos of x dx. So now if I write the integration of cos of x dx, it is going to be sin x plus c. So therefore integration of cos of x got replaced with a linear expression ax plus b and dx. So my answer is going to come sin of ax plus b upon a plus c. Now students, do you remember we had integration of sin x, we had integration of cos x, but we didn't have integration of tan x. Actually we have it, but we are yet to get the integration of tan x. We are yet to find the integration of cot x, sec x and cosec x. Keep watching my lectures, you will definitely be knowing how to get integration of tan, integration of cot, integration of sec and integration of cosec. So at this moment I do not have the integrations of tan, cot, sec and cosec because they were not included in my standard list of formulas. For the standard list, students, please watch my previous lectures on the formulas of standard functions. So here at this moment I do not have the formulas of integration of tan, integration of cot, sec and cosec, but I do have the integration of sec square x dx, and the answer was tan x. Integration of sec square x dx was tan x plus c. So students, I can go ahead and write integration of sec square ax plus b. So did you observe what's happening here? We are simply replacing the variable x by a variable ax plus b. So what my answer is going to come? My answer is going to come tan of ax plus b upon a plus c. So are you noticing? We are writing the exact same formula for integration of sec square ax plus b as the formula was written for integration of sec square x dx. The only change that we are doing is whatever answer we get, we always divide by the coefficient of x. We always remember to divide the answer by the coefficient of x. So students, if I go ahead and ask you the integration of cosec square x dx. So the integration of cosec square x dx was minus of cot x plus c. So therefore if I ask you now integration of cosec square ax plus b dx, so should my answer be minus of cot of ax plus b, and always remember to divide the entire answer by the coefficient of x, which is a here and plus c, isn't it? So integration of cosec square x dx. Further, integration of sec x into tan x dx. It was sec x plus c, isn't it? So now if I go ahead and ask you the integration of sec of ax plus b into tan of ax plus b dx. So my answer is going to be simply sec of ax plus b, and always remember to divide by the coefficient of x, which is a. So that was integration of sec x tan x. And if I go ahead, the last one, which is going to be cosec x into cot x dx. So the answer was minus of cosec x plus c, isn't it? So students, therefore if I ask you the integration of cosec ax plus b into cot ax plus b dx, my answer is going to be minus of cosec ax plus b, and always remember to divide the entire answer by the coefficient of x, which is a in this case, isn't it? So these were the trigonometric formulas, isn't it? The formulas for the trigonometric functions. Now again I am telling students, we are yet to get the integration of tan, cot, sec and cosec. Now you keep watching my videos ahead, keep watching my lectures ahead, you will definitely come to know how to find the integration of tan, cot, sec and cosec. Now students, let's move ahead. If you remember, integration of e raised to x dx, it was e raised to x plus c. So therefore students, if I ask you integration of e raised to ax plus b dx, it is going to be what? It is going to be again e raised to ax plus b, and always remember to divide the entire answer by the coefficient of x, which is a plus c, isn't it? One more, integration of a raised to x dx. So it was a raised to x upon log of a plus c. So therefore I can say integration of a raised to. Now again I am not going to make use of a raised to ax plus b. That will be slightly confusing. So what I am going to do here is I am going to change my linear expression to say a raised to mx plus n. Are you getting? What did I do the change here? I have changed ax plus b with mx plus n. So I can write my answer as a raised to mx plus n upon log of a. See, the answer remains same. A raised to x, the integration was a raised to x upon log a. So here also a raised to mx plus n, the answer is going to remain a raised to mx plus n upon log a. But the most important thing that you want to remember here is to divide the entire answer by the coefficient of x, and the coefficient of x in this case was m. So the entire answer gets divided by m. So I'm going to write m here and plus c. Students, we can keep on continuing with the formula list like this. Now what I want you to do is, as and when I have taken these formulas, make sure you also start noting them down while watching this lecture. Keep watching the lecture and accordingly keep noting down the formulas also. Now obviously there are some more formulas left from the standard list. For instance, there was say 1 upon root of 1 minus x square. So 1 upon root of 1 minus x square, you say it was sine inverse of x. So again, if you replace x with a linear expression, so what is going to happen is you are going to get the same answer, sine inverse of ax plus b. You should always remember to divide the entire answer by the coefficient of x, which is a. Or in this case, you can take some other coefficients also. So students, make sure that you know your corollary well, you know your formula list well, you try to apply the corollary into the formula list. Knowing the formula list makes your life very easy with integration. So students, this is all for this lecture. We will meet in our next lecture, and in the next lecture we will be taking some more important concepts on integration. Thank you so much for watching. Have a great day ahead.